Okay, so of course we'll go over a couple of things from yesterday because we don't need to go over all of them, right? And then you will notice I got 2 assignments here. But I want to do the lesson in between them first. Because the lesson is what you need to see to be able to do assignment 2, but it will also reinforce assignment 1. Aight? Aight. But first, so everybody should have been able to do number 7. Yeah? 513, sine is positive, so that's 13, that's 5, that's 13, that's 5. So then, of course, you shift sine to get the angle, which is, I can't remember, shift sine, 5/13 is, of course, 23 degrees. So the angle is 23 or 157. Determine the exact values for the other 2. Okay, so in quadrant 2, cos is negative, has to be adjacent, -2 over +3. Then you use Pythagoras to find the other one. It's 9 minus 4, so that's the square root of 5. So sine is root 5 over 3. And then you find the rest of them. That's the same for all of those, so I don't need to go over all of them, right? I said don't do 9 and 10. You'll be able to do 9 and 10 after today's lesson. Number 11, of course, if this is the case, that is 6, that's -8. So this is, of course, 10, doing Pythagoras, and then you find all the trig ratios. Now, since it's 6 over 10, 8 over 10, and 6 over 8, what would you do with those fractions once you wrote them? You would, of course, simplify them, right? So everybody should be good with 11. Now, 12 through 15 are all pretty similar type questions. Is there any ones that anybody wants me to do that you didn't, and you're like a little, ooh, I don't know? 15? Yeah, sure. So 15, point K24. So I don't have the X value, yes? But I have the Y value, it's 24, right? And it's 25 units from the origin. So the Y value, 24, would have to be up there, yeah? That has to be 25, because that's 25 away, right? That has to be 25. That has to be 24. That has to be 24, and then you would use Pythagoras. Anything else from 13 through 17? Spectacular. And then 18, 19 shouldn't have been a problem. 20, none of these should have been a problem. 20 always causes grief because, of course, you spend your time looking at the picture, not what it really represents. It tells you that these are all 45 degrees, right? So if the radius of the circle is 1, then this is 1, right? And then if that's 45, that's 45 in their 90-degree triangle, then we would just do trig. Everybody cool? All right. Now, what we're going to do today will make your life a little bit easier a lot of the time. So, let's flip over to page 203, special triangles. Yeah? We're all on 203? Okay. So these two particular triangles are very useful because they are used in architecture all the time, and they follow a very predictable pattern. So let's begin with this guy right here. I'm telling you it's a 45, 45, 90 triangle, yes? Where is the 90? The right angle. Obviously right here, yes? Which means the other two are 45 and 45. Agreed? Now, think back to, I don't know when you would have done this, maybe grade 8, maybe grade 7. If these two angles are the same, what kind of triangle is that? It's always a right angle triangle anytime there's a right angle in it. But this is another kind of triangle as well. Does anybody remember? Yes, Qui. What is it? It is an isosceles triangle, named after the Greek mathematician. Now, an isosceles triangle is very special. Why? You knew the name, but you don't know why it's special, Qui? Both the angles are the same. Now, if both those angles are the same, then what does that tell us about both of these sides? They are the same as well. So, do we have a measurement for this side? No, we don't. So what do we give it in math when we do not have a number for it? We give it a variable. Now, I'm not going to give it x and y because that makes things confusing because we're dealing with x's and y's right now, right? So I'm going to give it a different letter. I'm also not going to give it a or b or c because then that ruins Pythagoras. So I'm going to call this q. Everyone agree? Everyone's cool with that? Okay. What then is this side? Q as well. Everybody cool? Now, what would be the easiest number to assign to Q? 1. I can't assign 0. It's obviously a distance. So what's the easiest number to assign to Q? 1. Excellent. So if Q equals 1, then can you tell me how long the hypotenuse is? How long is it? No. It is root 2. Why? Square root of a squared plus b squared, which is the square root of 1 squared plus 1 squared, which is the square root of 2. Yeah? Root 2. Now, you people have done enough trig to know that do the lengths of these sides ever affect the size of the angles? No, they do not. So that tells me that if I ever have 45 and 45, these sides are always going to be this. All right? What do you mean always? What if this side was 8? Then what would this side be? 8. Then what would this be? This is 8 times bigger. This is 8 times bigger. So what would this be? You don't need to think about it. This is 8 times bigger. This is 8 times bigger. So what would this one be? I don't know how to ask this simpler. No. 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 Oh my goodness. We'll try this. 3/4 equals 32. And what goes there? What is it, Hayden? Why? What did you do here? You multiplied it by 8. So what do you do to the other one? Multiply it by 8. Now let's come back to here. I multiplied this by 8. So what do I do with that? How do you show that? 8 root 2. It must be my fault for asking the question wrong, right? Yeah, it always is. Multiplied this by 8, we multiply that by 8. What's the answer? 29! I don't know. Okay, that was painful. But we will carry on. We will soldier on regardless. So, how does this apply to the coordinate grid? Well, quite simply. We'll draw one here. And we'll put a 45, 45, 90 triangle in it. 45, 45. Automatically, since it's 45 and 45, what number could you put in both of these spots, even if you don't have a number? 1. 1 root 2. Right away, yes? What would happen if I put it over here? What would this be? Negative 1 root 2. What would happen if I put it down here? Negative 1. I should have done that red one up above. I always do that. Negative 1 root 2. And what would happen if I put it down here? 1, negative 1, and root 2. Yes? Which means you now automatically know the sines and cosines of 4 new angles. Yes? 45 sine is 1 over root 2. 45 cos is 1 over root 2. What's this angle? (135). So do you now automatically know the cosine, sine, and tan of 135? Because you've got all 3 of them right there, because it always works. And then, of course, you automatically know this one. What's that? 225. And you know this one. What's that? 315. Right? Everybody cool? So we remember that 45, 45, 90 always follows 1 root 2. This is a leg, this is a leg, and this is the hypotenuse. Everybody good? Now the thing about the 45, 45, 90 is even if I spin it around. So for example, I wrote it this way, right? 1 root 2. Agreed? Right? Even if I make this side yellow and this side purple, that should have been purple, this side purple, you can do it, right? Even if I spin it the other way and I put the purple there and the yellow there, it still works, right? Because it's 1 and 1. It's really easy to work with. I want to spend a lot more time on it because it's pretty simple to deal with, yes? Okay, the other one is slightly trickier. Let's have a look at that. 30, 60, 90. Now, 30, 60, 90 doesn't really mean anything to us, does it? Right? 45, 45, we know that it's got to be the same, Q and Q, right? 1 and 1, 8 and 8, 12 and 12, whatever, yes? But on this, we don't have any of that, do we? So what we're going to do is we're going to build up to some new knowledge, all right? Where would you say is the 30-degree angle? Pardon one? The right side, right here? Excellent. Where would you say is the 60-degree angle then? Obviously, the top. And where would you say is the 90? Obviously, it is the last one right there. Agreed? Now, since I have no measurements, we can't put any numbers here, can we? We just can't, right? Do we agree? We're stuck. But we can get some values, can't we? So let's put some letters in there. Now, since this is a 90-degree triangle, I can go ahead and use ABC, right? Everybody's okay with that? Okay. A, B, C. Yeah? Now, do I know something? What do I know? Can I do something now? Can I write something mathy with this information? I could write the cosine and the tangent and what's the third one? The sine. Can I do that for 60? Can I do it for 30? So there's lots of stuff I could do right now, yes? Which one do you want to work with, 60 or 30? Okay, so I know that the sine of 60 is what? B over C. What else do I know? The cos of 60 is what? A over C. Agreed? And the tan of 60 is what? B over A. Still don't have any numbers, do I? But do I have a mathematical tool that will allow me to get some numbers here? What is it? Your calculator. Can your calculator tell you the sine of 60? What is it? What? 0.866. That's a barfy fraction, right? Screw it. I don't want to work with 0.866. What's the cos of 60? 0.5. Well, that's a fraction I'm comfortable with, isn't it? What is that as a fraction? 1/2. Agreed? What else is cosine? So ka toa. What else is cosine? So ka toa. What else is cosine? Pardon? Adjacent over hypotenuse. Now, there's 60. What's adjacent? A. So what value must it have? 1. What's the hypotenuse? So what value must it have? Can you now find the third value? What is it? How do you find the third side of a right angle triangle? Pythagoras. So do Pythagoras. I'm not doing grade 8 Pythagoras for you. Somebody tell me that answer. Root 3. Now, of course, now you can make some more assumptions, right? 30 is the smallest angle, yes? So what's it across from? The smallest side. 60 is the middle-sized angle. What's it across from? The middle-sized side, because the square root of 3 is 1.73 blah, yes? Biggest angle, 90, is across from 2. Everyone agree? So that gives us this. If I say that is 60, what is this automatically? What? No, this line. Root 3. Which makes that 30. What does that make this? Automatically. 1. And this automatically? 2. What if I went this way? And I told you that was 30. What does that make this? 1. What does that make this? What does that make this? Negative root 3. Everybody with me? Now, 30, 60, 90 triangles are used all the time. As a matter of fact, if you look up, you will see a 30, 60, 90 triangle in this room, except it's been cut off at that end. Because that is a 30, 60, 90. Because they use it in architecture all the time. Everybody cool? So we remember, the 30 is opposite to 1. The 60 is opposite to root 3. and the 90 is opposite to 2. Everybody cool? Let's apply it. Turn the page over. Now, you already know how to draw a terminal arm. You already know how to find a reference angle. This is the new stuff, right? So, let's do the very first one. It's super easy. Where does the terminal arm for 45 live? First quadrant. Boom. 45. Make the triangle. 45. And fill it in. The reference angle is 45. We've identified the special triangle. It's a 45, 45, 90. Now let's put in our values. What's this? 1, what's this? 1, what's this? Root 2. And then all I want you to do is give me the sine, cos, and tan. Sine, 1 over root 2. Cos, 1 over root 2. Tan, 1. And they're all positive. Why? Because we're in the first quadrant. Ease peas, lemon squeezy, yeah? All right, let's do the second one. Where's 60? First quadrant. Is it a little or a big? It's the big one. So I got to go down here. There is my reference angle, which is 60. So what does that automatically make the top angle? 30. Now I know it's a 30, 60, 90 triangle. So what goes here? 1. What goes here? Root 2. 3. What goes here? 2. And then we do sine, cos, tan. Fill them in. What are they? Root 3 over 2. 1 over 2. And root 3 over. So it's just root 3. Everybody good with the first quadrant? Do you think it changes anywhere else? No. The only difference is we actually care about the reference angle now. We can't just use the regular angle. So where is the terminal arm in C? Quadrant 4. What's the reference angle? 30. Well, there's my 30. So what's across from 30? What? 1? 1? 1? Negative 1. What's here? Root 3. And what's here? So, do the sine, cos, tan. And the last one, you're going to do all by yourselves. What's the triangle we're using in D? 30, 60, 90 or 45, 45, 90? 45, 45, 90. Negative 1, negative 1, root 2. SCT. Yeah? Ease bees, lemon squeezy, right? Okay, you guys draw the next 4 by yourself. I will draw them as well. It will record while I'm drawing, but the screen will be off because I want you drawing them on your own. You may talk to your neighbor, of course, if you're still a little unsure. All righty then. Check your work. Make sure you did it right. Here they are. Can everybody work with these? Yeah? It's pretty easy when we know where the terminal arm is, right? So what's different in the next one? I don't know the terminal arm, so I have more than one possibility, right? So I got to see wherever it will work, right? Where is cos theta allowed to be negative? Right, quadrant 2 and quadrant 3, right? Cos theta is A over H, but it's also X over the radius of that circle, yes? Now, what do we know about H and R? They have to be something. What? They're numbers. Numbers can only be one of two things. They have to be positive, don't they? But my cos is negative, isn't it? So where does the negative have to be? It's got to be the x. So I come out here to negative root 3. Agreed? Now, my radius has to be 2. Yeah? Which also means I got to go down there, right? Which means that's 1 and 1, yeah? So is this a 30-60-90 or a 45-45-90? 30-60-90. What is this angle right here? Then 30. What is this angle right here? 30. Both the reference angles are 30. Is either one of those theta? No, because where do we start counting for theta? From the x-axis, yes? So there's two options. What's the first one? What's that? Why is it 150? Right. If I go all the way to there is 180, but I've gone back the 30. Right? So theta could be 150. What's the other one? What? 210. Because I go all the way to there is 180, but then I go 30 more. Everybody with me? Okay, let's look at the second one. Oops, that wasn't very good. Earlier, I drew a freehand graph, and it was perfect. I actually made one of these, where the computer made it, and I dragged it over. It was perfect. Ask the other class. They'll tell you. It was true. Not that you care. But when you're old like me, little victories are very important. You people have a great many big victories left in front of you. I'm done. I am. I got married. I have the kids. I bought a house. I bought a car. I go on trips. I have a job. I went to university. I graduated university. What's left? I guess grandkids is the only thing I've got left. But even that could go wrong, right? Right? I want to be no grandparent for at least 10 years. And it better be a grandparent through the son, because then at least he'd be 25. 15. I know it could be next year. It could have been last year, probably. I don't know how, right? Same with my daughter. Even my daughter, in 10 years, she'd only be 23. I don't want to be no grandparent when my daughter's 23. That being said, it's okay, but no. Okay, so what do we know about sine here? It's opposite over hypotenuse. But on the graph, it's y over r, yeah? R has always got to be positive. Sine's positive. So what quadrants are we in? Top 2. Got to be there or there, yes? Well, the r has got to be root 2. The opposite's got to be 1. So what triangle do we have? It's the 45, 45. So what's theta? What's the first theta? 45. What's the second theta? 135. Whew, you guys, so smart. It's crazy. What about tan? Tan's the toughest one. Why? Why is it the toughest one to put on the graph, though? What have you noticed about both of these two, where they're sine and cos? Yeah. Opposite over adjacent, so the hypotenuse isn't part of it. So it's not going to be beside each other, is it? Where's it going to be? Diagonal from each other, right? And also this screws you guys up because you all forget what's not written there, but really is there. Right? Well, you don't know which one is negative, but you know all of tan is negative. So could it be there? No. Could it be there? No. So it has to be in here, yes? Let's make it purple. Right? Okay. Now, opposite over adjacent, right? So that's the y and the x, yeah? That's the y, that's the x. So this one, the y is what? Is that a positive or a negative y? Positive y. So the y, the root 3, has to be positive. So what does that make that? Negative 1. What does that make this? 1 and this? Negative root 3. Which triangle am I using? 30, 60, 90. What's across from the root 3? Is that the 60 or the 30? So what's this right here? What's this right here? What then is first theta? You're sitting right beside you. The one of you said 150, one of you said 120. Which is it? So which is it? This is 60. In here, if I go all the way to there, how far did I go? But I didn't go all the way to there. I stopped. So it's 120. Aiden, you got to be more confident. Just because Hayden is right almost all the time doesn't mean he's right all the time. And then what's this guy? That's 300. Way to recover, Hayden. Shake it off. Come back fighting. Right? Yeah. You're like that little chicken in cartoons. You hear the bell, you come out swinging. You know that chicken? Foghorn Leghorn trains him to box. And the dog keeps ringing the bell, and the little chicken keeps beating up Foghorn Leghorn. Nothing? Nothing? Foghorn Leghorn, the giant rooster? No, not like the giant chicken from Family Guy. I have a shirt with Foghorn Leghorn on it, and it says cocky. Because Foghorn Leghorn is a rooster, and roosters are cocks. And I bought the shirt. No, it's not. No, it isn't. All right, we're done. Now, remember how I said not to do a few questions on the last 2 textbook pages, right? Well, if we were to go back and look, like number 8 we could do now, couldn't we? Because we know the sine of 30 is 1/2. And we know the cos of 30 is root 3 over 2. And we know the tan of 30 is 1 over root 3, right? If we were to go to the next assignment, and we were to do this is funny. I just found this out last class. Some kid I noticed this yesterday. The kid, whoever had the textbook here before me wrote the numbers in here, and I just photocopied it. I didn't notice till it was too late. But look closely. What did this kid do? Right here. What's wrong? Did it backwards, didn't he? What should be here? There's the root 3. What should be here? 1. Dumbass. I should try to find the actual book I copied this from and check the name and see who had it. There's a chance it was this one. What page are we on? Just out of curiosity. 198. No, that's my page. What was the page in the textbook?
96.
Oh, right, 96 in the textbook. Oh, it wasn't this one. Damn. So all these people know what they're doing. Oh, yeah. Yeah, I'll do that right now. So listen, please. Your job is to do 201 to 202 and then 205 to 206. Now, please notice I have done the unthinkable. Oh, no. All right? Okay, now, Jacob. I'll tell you what your this is my best guess, because I don't actually know. I didn't program the TI-84, but this is my best guess. Next year, now if you don't care about what I'm about to do, remember how yesterday when we used the calculator to work with the angles that were bigger than 90, and it always gave us a reference angle, except when we did cos, and it actually gave us cos 150? Okay, this is my guess as to why that is the case. In trigonometry, you very soon will stop using degrees. You won't use them anymore. You will change to radians, which on your calculator is the RAD, or the big R. All right? Radians work in a whole circle. All right? Now, a whole circle is 360 degrees, yeah? Okay. So when we work with radians, and I'm not going to say why, I'm just going to explain. Radians, circles divide into 90 degrees, 180 degrees, 225 degrees. I'm sorry, not 225, 270 degrees, and 360, yes? In radians, 180 is pi. 360 is 2 pi. So this is pi over 2, and this is 3 pi over 2. Okay? That's not really that important. But if we graph sine values, the sine of 0 is 0, yes? And the sine of 90 is 1. Everybody cool? And the sine of 180 is 0. The sine of 270 down in the third quadrant is -1. Everybody good? And then the sine of 360 is back to 0. And it makes this nice curve. And if I drawn it perfectly, this would be half a circle and this would be half a circle. Cool? Everybody good? Okay. Now, if I take cosine, the cosine of 0 on your calculator is what? Just do it, even though you know. 1. So I'm going to start up there, aren't I? What's the cosine of 90? 0. What's the cosine of 180? -1. Cosine of 270, 0. Cosine of 360, 1. And it makes this nice curve. Now, observe. See how the blue curve is on top of the red curve now? Your calculator is programmed, I think, to think in terms of the sine curve because it starts at 0. So it's shifting the cos when you do cosine. And you can see that 150 would be right about there, yes? And there they are exactly the same. That's my guess. Short of writing a letter to Texas Instruments, I can't even begin to guess why. Right? I've never even given it a second thought because when you do the work, 150, all you do is, oh, that's weird, but okay, it's 150. Reference angle's 30, blah, 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 blah. All right. Back to work.